DARPA, the research and development arm of the U.S. Department of Defense, plans to hold a flight demonstration of nuclear thermal propulsion, NTP, that would take a spacecraft into Earth's orbit in 2026. Eventually, the engine could be used to fly through cislunar space, the expanse between Earth and the Moon. The Moon's average distance from us is 238,855 miles. Perhaps the same technology could transport humans for long-duration spaceflight missions, according to the Office of Nuclear Energy. These could include going to Mars, for example. NTP won't launch spacecraft from Earth, though. That's because NTP is not designed to achieve the millions of pounds of thrust needed to fight Earth's gravitational pull. Once a spacecraft achieves orbit using more traditional chemical rocket propulsion, it will engage NTP rockets it's carrying on board. The Draco program began with a preliminary design from unmanned flight company General Atomics for a rocket engine reactor. Spaceflight companies Blue Origin and Lockheed Martin submitted 2 conceptual spacecraft designs to the program in 2021. DARPA is accepting applications in an open competition so that the project is not limited to the companies that are already involved. The defense agency is looking for detailed proposals that describe how engineers would design, develop, fabricate, and assemble the engine. Submissions are due August 5th. Scientists have been investigating nuclear thermal propulsion since the 1960s. When the nuclear engine for rocket vehicle application program was active, Los Alamos National Laboratory scientists helped develop and test nuclear rockets. If the Draco program works as it's intended, we could see a new generation of nuclear rockets zooming through space soon. They may even make it easier to reach Mars. Why nuclear rockets are more efficient than chemical rockets. Nuclear thermal propulsion starts with a liquid propellant, such as hydrogen, pumped through a reactor core. Inside the core, uranium atoms split in a process called fission, which releases heat. When the propellant heats up, it converts into a gas. At this point, the process is similar to other rockets, in which gas propellant expands and shoots through a nozzle, thrusting the aircraft away. NTP isn't the same as chemical propulsion, however. Chemical rockets produce water vapor as a byproduct when the chemicals are being burned, making them heavier and less efficient. Hydrogen byproduct in an NTP system is far lighter, so the rocket travels farther on less fuel. The amount of thrust you can get from a chemical rocket that combusts a specific amount of liquid hydrogen and liquid oxygen is 450 seconds. This is half the minimum thrust expected for nuclear-powered rockets, estimated at 900 seconds. Unlike propulsion technologies in use today, NTP can achieve high thrust to weight similar to chemical propulsion but with 2 to 5 times the efficiency, DARPA explains in a Space News story.